Section 5.3, number 31. We're going to rewrite this expression in terms of an expression containing only one cosine, or only cosines to the power of 1. So that we need to use the power reduction formulas. So the power reduction formula for sine squared x is 1 minus cosine of 2x over 2, and that times the power reduction for cosine, which is 1 plus cosine of 2x over 2. I can recognize that the denominator is going to be 2 times 2, so that's just 4. And the numerator is a factored version of a difference of two squares. So that's going to be 1 squared minus cosine squared of 2x. The problem is now I have another square in there, so I need to reduce that because I don't want any cosine squares. I want everything in power of 1. So I'm going to take that another step. I'm going to... So 1 squared is just 1. And I'll keep that minus sign. And the fourth, I'll just write right there. And the thing I'm going to replace is this guy. I'm going to use the power reduction formula again. And the power reduction formula for cosine is 1 plus cosine times 2 times the angle. In this case, the angle is now 2x. So 2 times that is 4x, all over 2. Okay, so now I'm going to factor out that fourth so I can see a little better. So I'm going to put the fourth out in front, and that way I just have 1 minus 1 plus cosine of 4x over 2. In fact, in that same step, I'll actually express that 1 as 2 over 2, so I can have a common denominator. Simplifying that further, I get... Let's see, 1/4 of 2 minus 1 gives me 1 plus cosine of 4x all over 2. Let's split up that 2 and split up that fraction into 1 over 2 plus cosine of 4x over 2, and then distribute that 1/4, and we get 1/8 plus cosine of 4x over 8. So I'm just distributing that 1/4 into the parentheses to get rid of the parentheses. And I think that is pretty good. I might take this one step further just to express it in powers of, it's already cosine in power of 1, but just to put that fraction out in front so I see cosine by itself as a power of 1. And I think that is a good final answer. There we go.